Okay, so let's talk about water and sustainability. So I would like for you to take a good look at this political cartoon and think about what you think it means in terms of water sustainability. Think about the three E's of sustainability and what the implications of this illustration are. And feel free to press pause and you can click to see my interpretation of this cartoon. But let's go ahead and move on. So we're going to talk about water and sustainability. So there was a reading posted from Sandra Postel, who from the Post Carbon Reader book that you've had a few readings from. So Postel, she's pretty well known in the sort of the water and sustainability realm. So she brings up some pretty good points in this in her part of her chapter, and I want to go over. So first of all, she stresses the importance of water. And I mean, it would be, I mean, I think it would be good if you would stop and just sort of think about all of the ways that you use water or water impacts your life, whether directly or indirectly. And we'll hit on a few of those as we go forward. But I want you to press pause and sort of think about the ways that why water is important in your life. And as Postel puts it, water is essential to virtually every human endeavor. I mean, there are very few, if any, things that we do in our society that is not in some way influenced by water. Again, it may not be directly, okay, maybe indirectly. Think about the food that you eat. Um, you're not drinking water while you're eating the food, but that food, no matter what food it was, had had to use water in order to be grown at some point, whether it's directly through plant matter or if it's meat, the what the meat, the living version of meat, whatever animal it was, had to eat, got its energy from plant matter. And if it ate another animal, well, that animal got its energy. So somewhere down the line, the energy in even meat that you eat comes from plant matter, and all plant matter requires water to grow. So you could go any number of examples. You mean the device that you're watching this presentation on, whether it's a computer or a cell phone or a tablet, in the production process of this item, there was some water used. Okay, so you can relate water to everything, and I'll go over a couple of examples here in a minute. So it is essential to, as she says, virtually every human endeavor. It's not only useful but essential. Now she goes over three reasons that she says that water is more worrisome than energy. I mean, we've talked a little bit about energy, and energy is talked about a lot, especially when you think about its impact on climate change. Water, unfortunately, is not as well publicized an issue, and so she sort of asserts that we should be worried about this, and she gives three reasons why. And here are the three reasons. First of all, water cannot be substituted for. Okay, it literally is no substitute for water. And if you think specifically with regards to energy, okay, so if oil runs out, yeah, not a good thing necessarily, but we can substitute for the stuff that oil does. The energy portion and the non-energy, so the plastics that you make out of it, the other products you make out of it. So we can substitute for basically anything else, but water absolutely cannot be substituted for. Nothing does what water does. Um, and then water is actually the basis of life, not just a commodity. So again, to use the example of oil, we can get, we don't technically need oil to live. Just about any other thing. We don't need copper to live. We don't need glass to live. We don't rubber to live. Name your thing. I mean, water, human beings cannot survive more than a few days, maybe up to a week without water. So we absolutely need it to live. So if we don't have access to clean, drinkable water, we're really in trouble. Um, and the third aspect is that it's through water that we will experience climate change most directly. So there are many aspects of water sort of problems that will be, I guess, the result of climate change if climate change continues to occur, whether it's sea level rise, whether it's flooding, whether it's drought, whether it's excessive rains, water shortages, and so forth. So water is one of the biggest ways that will be impacted. So fortunately for us, assuming you're sitting in somewhere in the United States right now, this is more of an international problem, right? I mean, you hear about water scarcity, you hear about drought internationally, but I want you to take a look at this chart. Um, that shows water stress areas of the world. Okay, so it's off the world map, and no stress is the green. You go to the blue, minimal, moderate. So red is the high stress. So I want you to press pause and think about any patterns you see in this map. Okay, so go ahead and press pause. And one thing you might notice, of course, right in the middle of the map here, you have North Africa, the northern part of Africa, very high water stress. Interestingly, some inland areas of Asia, south, kind of reaching into Southeast Asia. Australia has a pretty big water stress area. But one thing that may jump out at you is in the U.S., you think, well, yeah, we have access to water. Sure, we do. A lot of areas in the U.S. are not under water stress, but a lot of areas are under not only water stress, but high water stress. Okay, so I mean, there's basically a historic drought going on in California right now, and this is all the way reaching into the Midwest, where you wouldn't normally think of water scarcity, but we are having issues. So, I just wanted to put this map there to help you realize that this is not just an international problem. This is not a problem just in low-income countries. This is a problem in the United States as well. We are kind of in some ways, in a bad shape with water. Okay. So in this video, I'm going to introduce the concept of water scarcity. So take a look. Okay, so the first thing I wanted to point out here is that water scarcity is just when the demand for water is higher than the available resource. So it's pretty straightforward. We're under water scarcity conditions when we need more than we have, basically. And by the way, there is no sound right now. The sound is working on here. It's just part of the video has no sound, so that's why it's silent right now. So that's the first thing that I think is important to point out is that um, of all the water available for use uh, on the planet, only about 2.5% is fresh water. So salt water, there's very few things, and we can do it to using like cooling towers and some other niche type of uses, but we can't drink salt water. There are ways to desalinate it that we can use it, but most of the water is the vast majority of water in the world is not fresh water, so we can't really use it for very many things. So this may come as a surprise. If you actually take that small sliver, that 2.5% of all the water in the world, when you think of water, you probably envision lakes and streams and rivers and all that. So that would be the surface water. Of the 2.5%, so only 0.3% of the 2.5% of all of the water in the world is actually available in lakes and rivers. About 30% is groundwater, and then 69%, 70% is locked in glaciers. So even that small sliver of total water in the world, very, very, very small amount of that is very readily available for you. So like you can sort of see it and gather it really easily. A lot of it, I mean, the glacial ice, glacial water, we really can't use at all. So that gives you some perspective on, the water that we need to survive. Very little is very little of the total. So again, it is a big problem worldwide. Currently, around a third of people in the world are living under these water stress conditions, and then it's only going to get worse most likely. Climate change is a big factor of this, but population growth is also a major factor. So the first type of water scarcity, I want you to kind of write this down. The physical water scarcity is when there's not enough water to meet your needs. So in other words, the water's just not there. You need it, but we don't actually have it physically, which you may think is the only type of water scarcity, but there are more. Notice that the Southwest United States is part of this physical water scarcity. There's, think about the people that live in, Las Vegas and some of the, parts of Colorado and Nevada and Arizona and California. They need more water than it's actually there. And you can see it's expanding again. Africa, Mid-Central Asia, Middle East is a big problem. So this, I think, is a pretty important graphic. We'll go over a couple more numbers that are similar. So this is just agricultural use, and you can, these numbers. So the FAO is the Food and Agriculture Organization from the United Nations. They're a really well-regarded international organization. So you can trust the data here. And so what you see, notice you have the percent of all total water used for agriculture in various parts of the world. And you notice in North America, about 50% of all the water. Now, mind you, that's not all the fresh water. It's even more for fresh water. But most of the water in the world is used to grow food, is sort of the bottom line here. Okay, so here's the other type of water scarcity. So you notice economic water scarcity. The water is there. Okay, when it's economic water scarcity, the water is there, but we just can't get to it for whatever reason. Whether it's political or institutional, financial, whatever. The water is available, but it's just not sort of able to be procured. So you notice now there's a lack of economic scarcity in the U.S. We do have certainly the resources to get water, but sometimes it's just not available. And this is pretty common. This graphic is pretty common for just about any resource, whether it's energy or food or whatever. Generally speaking, the necessities of life in these sort of lower income countries of the world, they have to pay a larger percentage of their income on getting them, and water is included. Okay, so I'm going to kind of leave it there. Okay, so the two, I guess, big things there. We have scarcity. Water scarcity in general just means that the demand is higher than supply, so you just don't have enough to supply your needs, and then that's the distinction between physical and economic scarcity. These are important distinctions, I think, to keep in mind. So just to give you an idea of some of the evidence of water scarcity, this is actually in the United States, in Lake Mead out in the western United States. It's a pretty dramatic picture. So this is a big reservoir behind a dam. And so this supplies a lot. This is the Colorado River, I believe. This supplies a lot of the majority of the water needs in the west. California, Colorado, Arizona, I believe Utah. So you notice it looks pretty dramatic, kind of beautiful, really. But if you look at this sort of bleached part of the cliffside here, that indicates where the historical level of where Lake Mead used to be. And just in case you think that's not a lot, you see this ship here. This is a sort of a 3-story high. You notice there's 2 stories and then there's a tower. So this is a 3-story high. That's about a 30-foot, 25, 30-foot ship probably. It's dwarfed by this. So this is a major river, major source of water. 90% of Vegas's drinking water comes from this reservoir in Lake Mead. It's dropped 130 feet since 1999. There's not only the drinking water, but it's used to irrigate 1 million acres of land. It's kind of, it's just one indicator that water scarcity is a really big problem. You saw all those maps from the western United States with the water scarcity. This is one of those problems. And just to give you an idea, part of the problem is that I'm not going to go over this chart, but part of the problem is that if you dam up water, if you put it in a reservoir, it's going to evaporate more quickly than if it's running free. Okay, so this is just another chart. I'm not going to actually go over this. You can press pause and take a look. This basically mimics, you notice, another illustration of how little of the water on planet Earth is available as fresh water. Okay, and I think one thing is that's interesting to point out is that the supply of fresh water it's relatively constant. This is from the Pastel reading. Um, Basically, the water that's available now is the same water that's been available effectively ever since the world formed, the Earth formed, at least human civilization, right? So the water that's in, that's coming out of your tap, that can come out of your tap right now, has been on the Earth since the time of, Julius Caesar and the Egyptian pharaohs, and even before then, right? So the amount of water that we have on the Earth is not increasing. It's staying the same. Now you have some water that's going from salt water to fresh water, and fresh water going from groundwater to glacial, blah blah, etc. Okay, so water is moving around the hydrologic cycle, which we went over in the climate change lesson, but the amount of water effectively is fixed, so it's not increasing. We're not getting water from outer space or underneath this, the surface of the Earth too much, anything like that. So the problem is, as population, if you think about it, if the water stays the same, but the population grows, you're having less water per person or per capita as we move forward in time. And so the result of this is between 1950 and 2009, the renewable per capita water availability, so water is renewable, so it does cycle in and out of the water cycle, hydrologic cycle, it's actually dropped by about 63%. That's due just to population increase. So if you look at the per capita water usage, um, this is a map that shows your, what you could call water footprint, or kind of like the carbon footprint. So if you look at the amount of water used per capita or per person across the world, this is broken down by country. You can press pause and take a look, but obviously green is good, red is bad. And you may notice the United States is one of the worst offenders in terms of the per capita or per person water use across the world. And you have some other interesting, you have some of these very arid countries that have very high per capita water use per person, which is interesting. But really what I want you to get out of this is that, generally speaking, in the United States, North America, we're one of the highest per person or per capita water users in the world. Okay, so this was pulled from at least the time of this presentation in October of 2016. The U.S. Drought Monitor. You can go to this website at any time and find the current drought conditions across the United States. Again, this is just to hammer home. You look, red areas are bad. That's exceptional drought is the dark red. So you can see in California, especially in the Central Valley region, that's exceptional drought. I think this is, this kind of surprised me actually when I saw this, that we have places that are normally associated with these sort of like humid areas of the country down in Georgia and Mississippi that are actually experiencing droughts. But anyway, I think the one that really jumps out at you is probably California. So it's like, all right, well, that's California. That's California's problem, right? So I'm sitting here on the East Coast of the United States, over right around here. This is all the way out in California. That's not my problem, is it? Well, if you think about what they do in California, especially in this region, the Central Valley region of California, so 50% of all the U.S.'s fruits, vegetables, and nuts are grown in California. A lot of them in this region that's the Central Valley. It's the huge agriculture region. And so it's not just California's problem, it's the problem for people across the United States. When California is under drought, it affects everyone in the United States. And so, there are a lot of causes for this. I'm not trying to point fingers here, but I think this is, I remember when I had, a long time ago flown out to Arizona actually to visit some relatives, and I remember flying over the desert. So Arizona, the Phoenix area, it's surrounded by desert. Phoenix is basically in a desert. And I remember flying over and noticing things like this. So go ahead and press pause. I want you to think about what in the world is this? So this is a picture from an airplane. And I want you to think about what this sort of little amoebic looking splotch is. And so there's of course a lot of desert around. This is in the middle of the desert. This is of course a golf course. Obviously the grass is not native to the desert, all right? So if it were, then there would be grass in this area, but it's not. This is an arid region. Grass does not naturally grow there. I think one thing is kind of also interesting is that there's an awful lot of water. Don't get me wrong, I've golfed. I like to golf, but even golf courses on the East Coast that I hit, a lot of them don't have this much water. So not only are they growing grass in the desert, but there are big water features in this as well. This The source that I pulled this from is it was like a reporter or something, just her blog. And this quote just kind of struck me as, I mean, kind of sad to be honest. They look, desert golf courses look funny from the air, surrounded by desolation, as if the desolation is the odd part of this picture. You know what I mean? So, it struck me as pretty an odd way to think about it. I mean, for me, it was kind of the reverse. Like, desert golf courses look funny because they shouldn't be there. Not because they're surrounded by what was she called desolation. But just to give you one example, um, that the Palm Springs area of California, which is in a desert, there's 130 golf courses out there. Again, this is not to point fingers. I mean, there are a lot of reasons that we have water shortage issues across the world and in the United States. But to me, this is one that's a particularly egregious, that an example of what I would call the misuse of water, or the um, unusually inefficient use of water. Um, and so, if you think about why our golf course, so why would we put a golf course in the middle of the desert? So go ahead and press pause and think about that. It's just because it's money. I mean, Palm Springs, for example, is a big, there's a big retirement population. People go out there. It's a pretty wealthy area. People go out there on vacation and they want to golf. So it's all about bringing money into the area. Again, I'm not begrudging anyone for trying to make money off of this, but it's a pretty obvious, I would say, misuse of water resources in an area that's already stressed. Okay, so just a couple of things to point out from Postel's reading. Um, she notes that worldwide, that 70% of water worldwide is used on agriculture. So you can take these numbers with a grain of salt, but the main thing here is that water is the major user of fresh water across the world. And then you have industries, and you have cities and towns, which is the stuff that you use in your house, or you use at school or whatever. So you think about, a lot of times, I think a lot of the focus on water conservation is on what you use in your house, like turning off your faucet when you brush your teeth, taking shorter showers, and so forth. And that's all very important. It's an important aspect of water conservation. But I think the bottom line here is that agriculture is really the biggest. It's the biggest user of water. So if you want to make the most impact on water use, you should uh, uh, limit certain types of foods, and we'll go over that in a minute. And so the overall, according to Postel, we're going to need to double water productivity by 2025 to satisfy our needs. So water productivity just means, if it takes, let's say, 100 gallons of water to grow a tomato plant. Now, if we use 50 gallons later, that would be doubling our water productivity. So we really need to figure out how to use water more efficiently. So there are a lot of ways to do this. So we have conservation and efficiency. In the United States, we use the highest, twice the global average of per capita water use. Okay, and that's the direct. You notice here that this 1,800 gallons per day, about 1,300 per gallon is for food. Again, agriculture is the biggest thing here. And so her fundamental question is, how can we provide enough water to provide healthy diets for these 8 billion people? So population is growing. It's probably going to make it to 8 to 10 billion people by 2050, depending on who you ask. And we need to figure out, I mean, again, going back to the very first slide here, water is absolutely essential for life. It's not just a commodity, we actually need it. And throwing a monkey wrench into all of this is that climate change is going to make this worse. I mean, whether it's flooding, whether it's droughts, whether it's sea level rise, I mean, the availability of water is almost certainly going to be negatively affected by climate change. Okay, so I think a particularly startling image, and there are any number of resources out there that tell the same story. So I want you to go ahead and press pause and think about what you could call the water footprint of different products. So go ahead and press pause and just take a look at these and kind of soak in these numbers. And before you do that, note that this is in liters. So a liter, there's about 4 liters in a gallon. Okay, so what you may notice here is the different products that and the amount of water that's used on average to generate that product. A few, things I would think would jump out at you here. One T-shirt is about 1,000 gallons. Remember, this is in liters. That's about 1,000 gallons of water for a T-shirt. And it's not that, it's not in the factory production of the T-shirt. It's because cotton is a very water. It's a very thirsty plant. It requires a lot of water to grow, and so it's just from the water to grow the cotton to make your t-shirt. You look at leather, cow leather. One pair of shoes about 2,000 gallons of water just for a pair of shoes, a pair of leather shoes. And again, it's not because the cow's really thirsty. It's because of all the food that's grown to raise the cow. And a single hamburger, now this is a small, I believe this is a quarter pounder, if I remember correctly. So a pound of beef generally is about 1,000 gallons, if not more. So maybe this is a half-pound hamburger. But think about that, a single pound of beef is about 1,000 gallons of water. And again, it's all because of the stuff that the cow eats. It's not that the cow, uses a lot of water. It's in the US especially, it's because we grow corn to feed the cows, and it's all the water that's used to grow the corn. Even things like a cup of coffee, I mean, it takes water to grow a coffee tree. Even a single egg, 135 liters, so 45 gallons or so of water. Anyway, so I think the story here is that it's not what you use directly that's really the issue. It's really what you would call indirect water use. That's the big problem. Okay, and so her solutions, again, this is all about agriculture. It's all about growing food, or growing crops anyway. And so you can do more efficient irrigation. We'll go over this example in a minute. That's a really big way to do it. You can try to boost the yields on existing farms and focus on rain-fed farms. Eating less water-intensive diets, very, very effective way to do this. So if you think about these numbers, if you take the amount of protein that you get in any amount of beef to get the same amount of protein from rice. Okay, so let's say you're getting 8 grams of protein, whatever that is, a couple ounces of beef. To get 8 grams of protein from rice, it takes 400% or 4 times more water to get that from beef. Okay, so think about that. Same amount of protein takes 400% or 4 times more. And that's just for protein. For the calories, to get the same amount of calories, so let's say you're getting 500 calories of beef. To get 500 calories of rice, it's almost 20 times the amount of water to get it from beef. And so I hate to say it. I know meat's delicious to a lot of people, but the single best thing you can do to reduce your water footprint is to cut back your meat consumption, especially beef. Put down the hamburger, guys, and walk away. It really is the most effective way, again, especially for beef. Now, you could also, there's some other suggestions she makes, using trade to make the smartest use of water. So if you think about it, she kind of mentions that when you import goods, so let's say we get, beef from whatever, New Zealand or Brazil, so we import Brazilian beef. In a way, we're actually effectively importing water from Brazil, because there's this huge, all the water that's used in Brazil to, raise that cattle ends up being used for beef that we eat. So you can kind of be smart about trade, and if you have areas that have excess water, so if we want to have beef, maybe we should get it from areas of the country or the world that have more access to water, and so we're not stressing out areas that are already water stressed because of our high protein diets. So that's one way you can kind of do it. She's also mentioned sending market signals. I think this is important. There's very little incentive out there, at least in the United States, for reducing water use. And this is a really good way to do it. In fact, in a lot of ways, the U.S. government subsidizes water, so it's a lot cheaper to use than it actually should be. So I think this video does a really good job of illustrating some of the issues with water footprint. Okay, so I just think that's a pretty interesting video, a good way to illustrate some of the issues with water scarcity. Okay, so let's move on to a brief discussion about irrigation. Now, this will be addressed in the part of the course about food, but I wanted to bring it up right now since it is very much apropos to what we're talking about in this portion. So if you look at this is something called central pivot irrigation. Okay, so this you've probably seen this if you live in an agriculture area, if you've driven by an agriculture area, you may have seen this huge piece of equipment. This is good 15, 20 feet tall up to here, and then these are basically big water sprinklers. And so this is called central pivot irrigation. If you've ever flown over the Midwest or an area that's an agricultural area, you may have noticed these circles. Okay, so these are big circles on the ground. This is from an airplane. And so this is the result of central pivot irrigation. So the way this works is you have these big pieces of equipment, okay, and so there's in the middle here on this far end there's a water source, okay, and so the water is fed into there and then runs through here and then it sprinkles out. So this is called central pivot. So if this were the piece of equipment here, the end here would be right in the middle of this circle, and then the equipment goes out like this, and then what it does is with these wheels it slowly moves around in a circle. Okay, so it's out here pivoting from the middle, slowly moving around in a circle, and then irrigating that area. Very effective way. I mean, it's effective in that it's useful, and it's not a real heavy high technology. It's all mechanical. There's nothing electrical way here. It's just it runs on water. Well, there may be a little bit of motor that's running these wheels. Okay, so the point here is that it's useful, but this method, about 40% of the water does not reach the ground. Okay, so 40% of this water, is shooting up in the air, it's blowing away, it's evaporating, and so forth. So a lot of it, the reason you're doing this is to water the ground, and about 40% of it's not actually reaching the ground. So there is an alternative to this, something called non-spray or drip irrigation. And this is, a close-up. You can see these long tubes that just run along the plant. So it basically directly waters the ground, doesn't spit it up into the air, which minimizes evaporation, minimizes the amount that's blown away. So you compare the two processes, and about 40% of the water is lost in this method, and about 10% of the water is lost in this method. So it's a much more efficient way to do it. Now, it's not necessarily the easiest way. Obviously, this is not as labor intensive. You don't have to lay these long pipes all along these rows. But, it's not an easy solution, but it is a reasonable solution in that it does work. And so I guess the point is, if we did become more concerned with our water use and worried about water stress, there are ways to address that huge number, that 50 to 60 to 70% number of water use in agriculture. We can cut that down significantly by being a little smarter about irrigation. Okay, so I'm going to stop there and pick up the rest of the lesson in the next video.